Imagine our planet Earth drifting towards Jupiter. Could this happen? What would it be like? The thought is both terrifying and fascinating. Let's explore this cosmic what if. While the scenario is highly unlikely, thinking about it helps us understand the universe better. It reveals the immense power of gravity and the incredible forces at play in space. Join me as we dive into this hypothetical disaster. Jupiter is huge. It's so massive that it could fit all the other planets in the solar system inside it, and there would still be room to spare. Imagine that. It's the largest planet in our solar system, and by a significant margin. Jupiter's diameter is about 11 times that of Earth, making it a true giant among planets. If Jupiter were a basketball, Earth would be the size of a grape. This comparison really puts into perspective just how enormous Jupiter is compared to our home planet. That's a big difference. But size isn't the only thing that makes Jupiter fascinating. Its composition and structure are equally intriguing. Jupiter is a gas giant, meaning it doesn't have a solid surface like Earth. Instead, it's composed mostly of hydrogen and helium, the same elements that make up the Sun. Instead, it's a massive ball of swirling gas and clouds. These gases are in constant motion, creating a dynamic and ever-changing atmosphere. These clouds are made up of different gases, including hydrogen and helium. The upper layers of the atmosphere are where we see the most activity, with clouds forming and dissipating rapidly. They create the beautiful bands and spots we see on Jupiter. These bands are actually strong jet streams that can reach speeds of up to 400 miles per hour. One of the most famous features is the Great Red Spot, a giant storm bigger than Earth. This storm has been raging for at least 400 years and possibly much longer. It's a high-pressure region with winds that can reach speeds of up to 400 miles per hour. Jupiter also has a fascinating system of moons, with over 79 known moons orbiting it. The four largest, known as the Galilean moons, are Io, Europa, Ganymede, and Callisto. Each of these moons is unique and has its own set of interesting features. For example, Europa is believed to have a subsurface ocean beneath its icy crust, which could potentially harbor life. This makes Jupiter not just a king of planets, but also a key player in the search for extraterrestrial life. Jupiter's magnetic field is another remarkable feature. It's the strongest of any planet in the solar system, about 20,000 times stronger than Earth's. This powerful magnetosphere extends millions of miles into space, capturing charged particles and creating intense radiation belts. These interactions between Jupiter's magnetic field and its atmosphere create stunning auroras at its poles, similar to the northern and southern lights on Earth, but much more intense and spectacular. Our understanding of Jupiter has been greatly enhanced by spacecraft missions like Juno, which has been orbiting Jupiter since 2016. Juno has provided us with detailed images and data, revealing new insights into Jupiter's atmosphere, magnetic field, and interior structure. Thanks to these missions, we continue to learn more about this giant planet, uncovering its secrets and deepening our understanding of the solar system. Jupiter truly is the king of planets, a majestic and awe-inspiring world that continues to captivate our imagination. Jupiter's enormous size gives it incredible gravity. Gravity is a force that pulls objects towards each other. The more massive an object, the stronger its gravity. Jupiter's gravity is so strong that it affects the orbits of other planets and asteroids in our solar system. If Earth were to get too close to Jupiter, this powerful gravity would pull us in. It's like a cosmic magnet that's hard to resist. But what would happen as Earth fell towards this giant? As Earth fell towards Jupiter, we would feel Jupiter's gravity getting stronger. Our planet would start to stretch and distort. The tides would become more extreme, causing massive floods. Earthquakes and volcanic eruptions would shake our planet violently. The closer we got to Jupiter, the faster we would fall. We would be accelerating towards our doom at incredible speeds. The journey would be a terrifying roller coaster ride with no happy ending. Section 5. The atmosphere, a deadly cocktail. Jupiter's atmosphere is a deadly cocktail of gases. It's mostly hydrogen and helium, but it also contains ammonia, methane, and other toxic substances. These gases would be lethal to humans and most life on Earth. As Earth plunged into this toxic atmosphere, the extreme temperatures and pressures would start to rip our planet apart. The heat would vaporize our oceans, and the pressure would crush everything in its path. Section 6. Crushing pressure, Earth's demise. The pressure inside Jupiter is immense. It's millions of times stronger than the pressure at the bottom of our deepest oceans. Imagine the weight of hundreds of elephants standing on your toe. That's the kind of pressure we're talking about. As Earth descended deeper into Jupiter, this crushing pressure would start to compress our planet. The once mighty Earth would shrink and contort, its structure collapsing under the immense force. Section 7. Jupiter's interior, a swirling abyss. Jupiter, the largest planet in our solar system, is a world of extremes. Its atmosphere is a chaotic dance of swirling clouds and violent storms, a mesmerizing yet terrifying sight. Eventually, Earth would reach Jupiter's interior. As it descends, it would pass through layers of increasingly dense gas, each more hostile than the last. The journey would be like diving into an ocean of gas, where the pressure and temperature rise dramatically with depth. This is not a solid surface, but a swirling abyss of metallic hydrogen. Here, the hydrogen, which is normally a gas, is compressed to such an extent that it behaves like a metal. This metallic hydrogen is a key component of Jupiter's interior. Metallic hydrogen is a strange state of matter that only exists under extreme pressure. In laboratories on Earth, scientists have managed to create small amounts of metallic hydrogen, but it requires pressures millions of times greater than atmospheric pressure. It behaves like a liquid metal, conducting electricity and generating a powerful magnetic field. This magnetic field is one of the strongest in the solar system, and it plays a crucial role in shaping Jupiter's magnetosphere. Earth would be completely disintegrated in this chaotic environment. The intense pressure and temperature would tear the planet apart, reducing it to its basic elements. Our planet, once teeming with life, would be reduced to its basic elements, swirling around in the heart of a giant planet. These elements would become part of Jupiter's vast and dynamic interior, a swirling abyss that continues to fascinate and mystify scientists. Earth's transformation from planet to debris, the remnants of Earth would become part of Jupiter. Our planet's atoms would be scattered throughout Jupiter's atmosphere and interior. It would be a complete and utter annihilation. While this scenario is hypothetical, it highlights the power of gravity and the incredible forces at play in the universe. It reminds us that even planets, seemingly solid and permanent, are subject to the laws of physics. The aftermath, a changed solar system. Imagine a scenario where Earth, our home, falls into the massive gas giant, Jupiter. The consequences would be far-reaching and dramatic, altering the very fabric of our solar system. If Earth fell into Jupiter, the solar system would never be the same. The gravitational dynamics would shift, causing a ripple effect throughout the entire system. Jupiter, already the largest planet, would gain even more mass, making its gravitational pull even stronger. Jupiter's gravity would be slightly stronger, affecting the orbits of other planets and objects. The delicate balance that keeps our solar system in harmony would be disrupted. Moons and smaller celestial bodies might be pulled into new, unstable orbits, leading to potential collisions and chaos. The asteroid belt, influenced by Jupiter's pull, might send more space rocks hurtling towards the inner solar system. This could increase the frequency of asteroid impacts on planets like Mars and Venus, and even the remaining moons of Jupiter. The loss of Earth would be a catastrophic event for life as we know it. Our planet, with its unique conditions, has nurtured a diverse array of life forms for billions of years. Its sudden disappearance would mean the end of countless species and ecosystems. Our planet is unique in its ability to support a diverse biosphere. From the depths of the oceans to the peaks of the highest mountains, Earth is teeming with life. The intricate web of life that has evolved over millennia would be lost forever. Its destruction would mark the end of an era. The void left by Earth would be a stark reminder of the fragility of life and the delicate balance that sustains it. The solar system would continue to exist, but it would be forever changed, a testament to the impermanence of even the most seemingly stable celestial bodies. A hypothetical disaster, learning from the impossible. Though the idea of Earth falling into Jupiter is terrifying, it's important to remember that this is a highly unlikely scenario. Astronomers believe our solar system is stable, and such a collision is improbable. However, exploring these what-if scenarios helps us understand the universe better. It sparks our curiosity and pushes us to learn more about the cosmos and our place within it. The beauty of astronomy, exploring the cosmos. Astronomy is a fascinating field that allows us to explore the wonders of the universe. By studying planets, stars, and galaxies, we gain a deeper understanding of our place in the cosmos. So the next time you look up at the night sky, remember the hypothetical journey we took to Jupiter. Let it inspire you to learn more about the universe and all its mysteries.